Okay, let's share screen, share screen. Okay, virtual learners, you need to press pause and you need to copy this down. Once you have this copied down, then continue watching the lesson. Okay, all right, y'all. I have to re-record this because apparently my video only has half the sound, like my mic went out. So I am recording this, just so you know. All right, here we go. So for this lesson, you guys are going to have a reference sheet. You get to use this for multiple lessons. That's why I copied it on its own sheet of paper. There's nothing on the back, so you need this for several lessons. Everything this week and even into next week. So this reference sheet is what you are going to go back and look at, because what we're going to be doing over the next several weeks is talking about how we are going to prove that triangles are congruent. So we already talked about if triangles are congruent, their statements are written with purpose. The first letter matches the first letter of the other one. The second one matches the second letter. We talked about all of that. We know that they have 6 parts that can be congruent. The sides can be congruent, so can the angles. But this says, okay, well, what if we don't know all 6 parts? That's fine. We can still prove congruency under these conditions. Okay, so the first thing is that they have side, 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 which means that you know all 3 sides. If you know that all 3 sides are congruent, then that means all 6 parts are congruent and that those are congruent triangles. Side angle side, the angle is the included angle, our included angle. So we could know this side and this side, this side and this side. Where would the included angle be? Up top. Okay, so it would still be up top. Angle, side, angle. That has the side included. So we could know this angle and that angle. The side would be the one in between the 2 angles. Angle, side, angle. This one is angle, angle, side, which is 2 angles and the opposite side. It could be either of the sides that's not included. So the only side it's not allowed to be is the included side, so I'll just mark this one. But if you know those 3 things, then you know that those are congruent triangles. Knowing those 3 things for the first 4 allows you to prove triangles congruency. So you don't know all 6 things, but you know 3 things. If it happens to be in this manner, you're good to go. Now, the one that's special is the hypotenuse leg, and it only applies to right triangles. So if you've got a right triangle and you know both of the hypotenuses are congruent and one of the legs, then you know those triangles are congruent. So that's how you can prove congruency. We're going to be doing that today in the form of a 2-column proof. Okay, so that's what we're going to be working on. Yeah. Yep. And this is really awesome in the fact that they give you the reasons. Okay, because you know with your 2-column proof, one side is your statements, one side is your reasons. Well, you only have 3 options when it comes to the sides. Okay, those 3 options are that it's given, that it's the definition of the midpoint, or that it's reflexive. Remember that reflexive is like when it equals itself. So like side AB equals side AB. That's going to be your reflexive. Or angle A equals angle A. That's reflexive. Or it could even be the congruency statement. Now, these are your reasons for angles. So if you are trying to prove that angles are congruent, You actually have 1, 2, 3, 4, 5, 6 options. But these 3 only apply if they tell you you have parallel lines. Otherwise, you just have given, vertical angles, or angle bisector. And you can't pull angle bisector out of the blue. Like, it has to tell you that there's a bisector. And then if they do, then you could use that one. Same thing with vertical angles. Vertical angles are the one that touch noses. So if you're dealing with a situation that has those type of angles, then you can use that. But you can't just pull that out of the blue. Okay? The last thing at the bottom is your congruent, or your corresponding parts of congruent triangles. This just basically means all of your parts are going to be congruent. We've already talked about this, so we're just going to jot this down quickly. AB is congruent to AD. BC is congruent to EF, and I'm just looking at the name, you guys. I'm just following the name up here. AC is congruent to DF. And I should make these congruent. Same thing with the angles. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. You could mark them up. Like so. That's a reference sheet. Keep that close, set it to the side so that we can do today's lesson. All right, today's lesson focuses in on the first 2 only. So today we're just going to be talking about side, 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 and side angle side. The angle is included, okay? So with this first one, this is just your rule box. So it's just the rules. It just says that if AB is congruent to DE, okay, and then the other side is BC is congruent to EF, and AC is congruent to DF. If that's the case, if all 3 of those are congruent, then the triangle ABC is congruent to triangle DEF. Okay, all that's just informational. So now let's actually figure out what is going on. Okay. So, first one here, okay? It says PQ is congruent to ST. That's given information. So, on the first part of my proof, I just write the word given. That's given. They told us that. So, we used this. Then, number 2 states the second thing. QR is congruent to RT. So again, given. There's one more given bit of information, and it says that R is the midpoint of ST. So again, that's given. Okay, so if this is your test, you have over 50% done just on your givens. So don't ever just get up here and be like, I can't do two column proofs. Like, I hate them. I can't do it, and not answer it. You can at least do the givens. Then after the given, look at the next statement. Line segment PR is congruent to line segment RS. Why are those 2 things congruent? The midpoint is cut it in half. Now look, it's a side. So you only have its given, definition of midpoint, or the reflexive property? So which one is appropriate for our situation? Definition of midpoint. Now, the last one is going to be either SSS, SAS, ASA, AAS, or HL. Okay, so it's going to be any of these options depending on which one you used. Now, for these, it's like, duh, it's going to be SSS because that's what we're working on. But when you don't have it specifically identified that way, look at your congruency statements. That congruency statement is talking about a side. The next congruency statement is talking about a side. 3 is not a congruency statement, so I skip number 3. 4 is a congruency statement talking about a side. So when they're all jumbled together and you're not sure what we're actually talking about, this method is going to make your life so much easier. So you know it's side, side, side. Just like that. And ta-da. Now, look at number 2. Okay, here's our picture. Here's our given information. I like to go through the given and fill the table out at the same time, so I'm not doubling up my work. So first thing on the given is JL. JL, this one right here, is congruent to MN. So I've got it marked with the hash marks, and I'm coming down here and I'm writing the word given. So got that one done. Then number 2 says K is the midpoint of JN and LM. So that's the midpoint. So that's easy right there. That's the given. Then it says that JK is congruent to KN. Well, how do they know that? That's right. JK and KN. You know that because of the definition of the midpoint. What about number 4? LK and KM. That one's also the definition of midpoint. So, how do you know that these triangles are congruent to one another? Side, side, side. SSS. Okay. Everybody got that? Number 3 is an empty one, which is fine. No big deal. What we need to do right here is we need to start with what? Given. AC is congruent to AD. That's our first given statement. And then we actually have another one, so we list that next. CB is congruent to BD. Okay, this is the first example that I'm showing you that what this looks like, but you are going to have bunches and bunch. Do you see that A and B are shared? That those two triangles meet up and come together and share that AB, right? So what you're going to do when you see that is you're going to say AB, or whatever it is, JK, LM, whatever it is, equals itself. AB equals AB. Well, what's your reason for that? It's either given, definition of midpoint, or reflexive property. It's a reflexive property. Anytime your triangles share a side, it's the reflexive property. What's going to be number 4? Good. You put the prove statement here. ABC equals ABD. You write that there. The prove statement is at the bottom, and then you tell me how. So how do you know that? SSS. All right, jump to the rule box. We're going to do this quickly. This is talking about the side angle side. So they're saying if AB is congruent to DE and the angle B is congruent to angle E and side BC is congruent to EF, then triangle ABC is congruent to triangle DEF. So we are able to write a congruency statement if we know side, included angle, side. All right. So here we go. Sample side angle side. So here's our proof. Looks like we have a rectangle that has a diagonal creating two triangles. We want to prove that those two triangles are congruent. So what's the first two, 1 and 2? Both of those are given. They told us that JM is congruent to NL. That's given. And then they told us that angle JMN, so this angle down there, is congruent to LNM, this angle there. Now, the next statement says MN is equal to MN. That's the reflexive property. How do you know that the triangles are congruent? S, A, S. Again, if you're confused, look at your statements. Look with me. This one is about a segment, which is a side. Number 2 is about a angle. And number 3 is about a side. Now look, okay? It doesn't have to be written in that order. Okay, sometimes they will be out of order, but what you need to look at is the actual triangle. So if we're looking at the triangle, we have the outer side and the middle side and the angle that's in between those. So that is side, angle, side. And know that this is not an option. Do you see that? It's not an option. It's not going to be that one. So if you get that, not an option. Also not backwards. Okay, not an option. So those are not going to be it. So even if they give it to you out of order, like give yourself a little giggle and put it in the right spot. But don't put this on your paper. Okay? That's supposed to be funny. Usually I say it, but I'm on Zoom and I just feel a little intimidated. Like I don't want any parents like watching in the background or listening in the background and be like, what did your teacher just say? Exactly. Okay, let's look at number 5. Number 5. AB is congruent to BC. That is given. Then BD bisects angle ABC. So that alone should like have your little mind triggered that we are probably going to be using this angle bisector somewhere. They just said bisector, so we're probably going to be using the angle bisector, okay? Connect things, connect the dots. So then the next statement says angle ABD. Angle ABD. This little one here is congruent to CBD. This one there. Well, how did that happen? Or why do we know that's true? Yeah, the definition of angle bisector. You knew it had to be that. They just told us that there was a bisector. Up above, they talk about a bisector, so we're definitely going to be dealing with an angle bisector. Now, below it, it says, BD is equal to itself. That's the reflexive. Y'all, we use reflexive so much. So just get used to using that one. How do you know that these are congruent? SAS, the included angle. Again, you've got that flat horizontal piece and this like wing area. So side, included angle, side. Okay? You start this one. See how far you can get. I'm just going to give you a second, though, because class is almost over. While y'all are working, I'm going to pass out your homework. You're not going to do all of this. I'm going to tell you what you're going to do. So don't like teachers, part of this interruption. Students, if you write the 7, you'll get on 89. If you write 78, you'll get on 31. If you write 258, you'll get on 224. If you write 413, you'll get on 89. If you write 424, you'll get on 102. And if you write 485, you'll get on 52. Okay, I hate to rush you, but we need to wrap this up. So let's answer. What's number 1? Given. Number 2. So since that's the midpoint, this is going to be definition of midpoint. What's number 3? Those are vertical angles. Very good. We're talking about the 2 that touch on the nose. Those are vertical angles. What's number 4? Again, definition of midpoint. And SAS. Again, you've got side, angle, side. Okay, I want to do this last one with you because this is the first one that talks about parallel lines. Parallel lines are the ones that give the students the most trouble. So the first 2 say that HI is congruent to GI, so that's given. Then it also says that HI is parallel. So these 2 are parallel. Now, what you can see or what you can know is that this diagonal right here is cutting those parallel lines. Even though we don't see it extended, it is cutting those parallel lines. And what do we call something that cuts the parallel lines? A transversal. So we're dealing with just our typical like parallel lines and a transversal, but we got to figure out what we're actually talking about. So they are talking about GJH. So GJH would be this angle here. And then we have IHJ. IHJ is this one here. Now, what would you say that these two angles are in terms of parallel lines? Well, if you don't remember, she's correct, but if you don't remember, it's going to be one of these three options. It's either alternate interior, alternate exterior, or corresponding. So what's our case for this one? Alternate interior angles. Then it says HJ equals HJ. What's that? That's the reflexive. And triangle GJH is congruent to IHJ. How? Your homework is only the proofs, because that's what we did today. Don't cross out and like get those out, because we're going to do those next class period on Wednesday. But for tonight, you're just doing 7, 8, is it 7, 8, 9, and 10? Yeah, just 7, 8, 9, and 10. Submit that. Then you will resubmit when you have all of it done. I did give you guys until Wednesday. Did you hear me say? Well, Tuesday at midnight. Okay, it's due Tuesday at midnight. So if you don't want to do it tonight, you can do it tomorrow during the day while you're sitting at home, but turn it in. Make sure you turn your homework in. Okay. Can you still hear me? Yes.